Hi everybody, my name is Caitlin Cross and I'm here to talk to you about my undergraduate dissertation project, tracing the fate of wild Great Crested Newts using photographic capture-recapture. So before we begin, I just wanted to give a little bit of information about myself. I am an undergraduate student at the University of Salford, studying wildlife and practical conservation. The first 2 years of my degree were super interesting and provided all of the key information needed for a career in wildlife conservation. However, the topics covered were quite broad, so I decided to take a year out and do a placement at Chester Zoo, where I was able to shadow the site ecologist. This involved working with and monitoring our native species, which I absolutely loved, and it was here that I decided that I would pursue a career within ecology. So when I returned to university for my final year, I decided to select a dissertation based on Great Crested Newts, the largest and most protected of our 3 newt species in the UK. And that's what I'm here to talk to you about today. As adults, they begin moving to water bodies from their overwintering terrestrial sites between late February and April. Although movement is staggered, with some individuals not reaching ponds until early May, a surge is usually witnessed during and immediately after humid periods. It's also worth noting that males tend to arrive to the pond before females. To attract females, males will use an intricately choreographed courtship display. Females will then lay approximately 200 to 400 eggs per season, individually wrapping them in aquatic vegetation to protect against UV light and predators. After breeding, adults will leave the pond between late May and July. On land, they remain active until October, then October to February is a time of hibernation. For the larvae, eggs hatch at 4 weeks and limbs develop after 6. Metamorphosis is complete at about 5 months, where they will develop into juveniles. They will then leave the water body in October for winter dormancy. However, it is not uncommon for those that were late laid eggs to overwinter in the pond as larvae. Great crested newts become sexually mature after 2 to 4 years, yet up to 71% return to the pond before this. While returning juveniles do not mate, it is thought that resource access is more abundant in water bodies, driving the return. I wanted to make a clear acknowledgement that data for this study was provided by Dr. David Orchard. His thesis on the population structure and demography of great crested newts in agricultural landscapes of northwest England generated enough data to accommodate several research projects. Thus, he shared the raw image data for a single pond at Sevenfold Farm. All photographs of great crested newts were taken under license. During David's original study, a total of 29 visits were made to a pond at Sevenfold Farm in Greater Manchester between 2013 and 2016. 8 visits were made in 2013, 4 in 2014, 9 in 2015, and 8 in 2016. Surveying occurred between March and July each year to accommodate for the time that great crested newts returned to the pond to breed. Traps were deployed in the early evening around the perimeter of the pond, then retrieved the following morning. Any great crested newts that were found were placed in a water-filled box to prevent dehydration and then photographed in turn. The most efficient method for this photography was to place the newt on a flat transparent surface, which could then be lifted and a photograph taken carefully from underneath. This ensured that the images that were taken were clear, which was needed for analysis. In fields of conservation and ecology, capture-recapture has played an important role for many decades, and as a result, there are many techniques in practice to mark individuals. For amphibians, amputation and tagging are common, yet the matching of natural body markings is becoming more frequently used. The data collected in David's fieldwork resulted in something like the images shown here. Great crested newts have unique belly patterns, so you can reliably differentiate between individuals. To process David's images, I'd select an individual by eye based on its belly pattern, such as this one shown here in 2015. and use this to compare returns between visits that year. So this is the same individual returning at a later date. You can also use this to compare returns between years. So this is now in 2016. This helps to assess information about the population and its dynamics. This project is still a work in progress, but so far the data suggests an overall increase in the size of the population between 2013 and 2016. I have also looked at the age profile of the population as displayed by the graph on the right. For this, it was assumed that upon first visiting the pond, juveniles were at least 1, males were at least 2, and females at least 3. The most common age was 4, followed by 3, and the average age of the population was 3.8, ranging from 1 to 7. I plan to also compare the results to a paper published in 2019 by Orchard et al. That used a method of skeletochronology to compare the ages of individuals retrieved from agricultural ponds with those retrieved from favourably managed sites. When calculating returns, 39 individuals were discounted as they were first detected in 2016, which was the last survey year, so presence and absence could not be confirmed nor denied in subsequent years. However, looking at the remaining data, it can be concluded that the largest percentage of the population did not return at all, 62.24%. 38.76% of the recorded population returned at least once, 11.63% of the recorded population returned at least twice, and 3.1% of the population returned at least 3 times. I have also begun to look at the sex of returning individuals. The graph on the right shows how males are more likely to return than females. In fact, no females returned more than 3 times. I plan to investigate the reasons for this further, as well as doing some statistical analysis. In addition to this, I am now also looking at automatic recognition software. A secondary aim of my study is to critically appraise the automatic recognition process for identifying Great Crested Newt individuals year on year. The comparisons of provided images made by eye will be compared against comparisons made using automatic recognition software to test for accuracy. The ability to program recognition can improve the speed of comparisons and may also increase the accuracy of findings by removing the potential for human error. In a preliminary study by Hock et al. In 2011, the features and classification techniques for automated recognition of Great Crested Newts were presented in order to assess the feasibility of the method. The study concludes that it is viable, but advise a repeat using a larger data set. In 2017, Mattei et al. Compared several computer-aided photo matching algorithms across software such as WildID, i3S Pattern Plus, and Amphident. Recognition rates degraded with increased database size, yet improved considerably with a greater number of matching images present in the dataset. This was consistent across all programs. Whilst this is encouraging, further research is required to test the software in a practical environment. I'm sure you'll all agree that it is a fascinating topic and there's plenty more to look into. I'll be providing updates once my project is complete. I'd like to give thanks to my supervisor, Professor Robert Yelly, and to Dr. David Orchard for their support and guidance, as well as to the Natural History Society of Northumbria for letting me present today. If you have any questions regarding my dissertation or anything else, please do not hesitate to get in touch. Thank you.